Okay, ladies and gentlemen, we're going to start today's video. We are skipping lesson 1.1.4, but hopefully you feel pretty comfortable with the work we've been doing all along. We are starting 1.2.1, which is how do they compare? So we're moving a little away from graphing for a little bit, and well, as far as what we've done before, and going to something slightly new. Proportional relationships with graphs and tables. Now, you guys have talked about proportional relationships, but it's probably been a while. So we're going to be analyzing that a little bit tonight and then tomorrow. You may recall studying about proportional relationships in a previous course. You have in 6th and 7th grade. Today, we'll investigate proportional relationships in graphs and tables. Okay? So let's go into it here. Sorry, I got to get my little page turner right here. There we go. Okay, so we are going to do two problems. Now, for today, you will need some graph paper because we are going to be doing, look at what it says, problem 141. Make a table and a graph to represent each of the situations below. And this is problem 141 in your book. A, Parvin often cleans the dishes for her mother. She can clean 17 plates in 10 minutes. How many plates can she clean in different amounts of time? Now, what time? It doesn't say, just different amounts. And so we're going to make a table for it. Now, of course, how many dishes, how many of you guys like to wash dishes? That's probably one of my least favorite chores. I hate washing dishes. Thank goodness for dishwashers, but not all of you have dishwashers. And even if you do, sometimes there's some dishes that are just awkward to wash. Now, when you look at this and she says 17 plates in 10 minutes, holy cow, that's slow. I could probably do 17 plates in 1 minute. So I don't get what type of plates they are washing, but just work with us here, okay? If they're doing 17 plates in 10 minutes and it says how many plates can she clean in different amounts of times. Now, the fact that this is kind of vague is actually a good thing. Take advantage of it, okay? So first we want to discuss what is the independent variable. So which one of these two is kind of the basic that is going on regardless? Does the amount of dishes depend on the minutes, or does the minutes depend on the dishes? And the truth is that the number of plates she washes depends on the number of minutes. So that means we're going to put my input, or my x value, is going to be minutes. Okay, time or minutes. Okay, and then my output, or my y value, is going to be dishes washed. And you should be writing this down. These are the notes for you guys. I'm helping you out here. I'm starting you off, so you need to be following along with me. If at any point you fall behind, please feel free to pause the video and catch up. And then we'll go from there. Okay, unpause it whenever you're done. Okay, so different amount of time. Are we going to start with some negative numbers? Because, Mr. Ramirez said to go from -3 to +3. Does that make sense to go negative numbers here? No, it does not. What would it make sense? Because we can't have negative time. No, we can't have negative time. Don't be a smart aleck about it. Okay, so what minutes do you think we should start with? Well, some of you might say 10 or something like that. How about if we start with 0? Ladies and gentlemen, how many dishes can you wash in 0 minutes? Well, logically, 0. Cool. Now, at this point, you do have some options. Some of you might want to say, hey, well, how many dishes would they wash in maybe 1 minute? Or something like that. But why not? Let's just go the easy route here, guys. How many would they wash in 10 minutes? Well, 17. And what would be the next logical step? Well, what about 20 minutes? If she washes 17 in 10 minutes, what would I do to figure out how many she washes in 20 minutes? Well, if the amount of time doubles, the amount of dishes should double. So if she washes 10 more minutes, she should wash another 17 dishes. So she should get, what's 17 plus 17? Well, that's 34. Well, then what else? What about 30 minutes? Well, what would I do then? Well, if I add another 10 minutes, wouldn't I add another 17 plates? So if you add another 17 plates to that, you get 51. And let's go for another one. How about 40 minutes? 40 minutes? Well, you're catching the pattern here, right? It should be another 17 dishes. So that would be to how much? 68. One more, you say? Fine, one more. Let's go all the way to 50 minutes. And if you add 17 to 68, how much do you get? You get 85. Okay, now we're going to make a graph. Now think about it. Think about what we just did, okay? Can I make, or the first question you should ask is how many quadrants do I need for my graph? So do I need one quadrant graph or all four quadrants? All four quadrants implies positive, negative. One quadrant implies just positive. If you look at your table, all the values are positive. So we're just going to make a one quadrant graph. So on your paper next to your graph or table, and again, if you need to pause, please pause to copy this down. But we are going to make a one quadrant graph. Now, how many squares? You know what? It doesn't really matter. You will kind of figure that out. And you're kind of using our space here. I just kind of took some numbers there. So let's see if it works for me here. I'm going to start at 0. Now, X is my values here, so I need my arrows and I need my axes labeled, so X and Y. On X, I need to go from 0 all the way down to 50. So looking at this value, I think probably if I skip a line and say 10, 20, 30, see how I'm skipping a square every time, 40, and 50, that uses my space fairly well. I made it a little long here, so I'm actually going to shorten it up here. That graph right there, okay? Oh, and my X. Now the other thing, well, I'll tell you in just a minute. I'll come back to that. On my Y-axis, here's a tough one. Now, here's where you got to be careful, okay? What we want to do is we need to go by a consistent, constant amount on the Y-axis. So what I don't want you to do is just plug in some numbers that don't make sense. We could go, same thing, we've got to go all the way up to 85. Now that's going to be a little bit more challenging. Let me see. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, roughly 13 squares, okay? And that's going to be a little tough. I don't know. I'm going to have to think about it here what I did. What I could do is go, every square is worth 10. So that means this would be 20, and then 40, and then 60, and then 80, and then 100, okay? So that's one thing we could do. And then I need to, well, two things we got to address here. What's one thing I'm missing is labels. This down here should be time in minutes, and over on the y-axis should be dishes washed. We always put labels, okay? And over here, we need a title, Marvin's dishes, or something like that, okay? And now I plot my points. Now again, remember, this right here are my x values, and so they go down here on this axis here. So I want 0 and 0, that would be a point right here. 10 would be 17, so 10 is here. Now if this is 20 right here, 17 would be a little bit above it. That means this is 10, 17 would have to be somewhere around there. 20 is 34, so 20, and I go to 30, which would be this line right here. 34 would be a little bit above that, so right about there. 30 would be 51, which would be right above this line, which is 50. See that? It's 50. 40 would be 68. It's going to be a little bit below 70, right about there. And 50 is 85. 85. So right in the middle of these two squares. Again, this line here is 80. The top line would be 90. And there are my points. Okay? Now, as you see, these points right here do seem to go in a linear pattern there. So that seems to be working okay. In this case, I actually do not connect the points because we can't really have partial dishes washed, or I guess we could, maybe you could argue. So we're going to go with that, okay? So there's my graph for this first situation. Cool? All right. Hopefully that makes sense. And you got it written down. Again, if you don't have it written down, please pause, copy this down, and we'll go from there. Could your scales be a little different? Here is the other option I want to address. You could have done the following. And on the y-axis, you could have said, hey, you know what? I have to be consistent, right? I have to go up by a consistent amount. That's what you said, Mr. Ramirez, consistent amount. aren't these going by a consistent amount? Couldn't I just go by 0 and then 17 and then 34 and then 51 and then 68 and then 85 and then just go, oh, 10, 17, 20, 34, 30, 51, 40, 68, 80, or 50, 85. Couldn't I have done that? And the answer is, yeah, you could have. As long as these numbers are consistent, that works. But if they go by a different amount, you cannot do that. My preference actually was the other graph though, because it does, if you look at this graph right here, these numbers are going to confuse you, and it might be kind of tricky here to see, like, are they going by the same amount or are they not? It might be a little tricky, okay? All right, but that is an option that you could have done. Let's go to the second one. Yasmin's puppy, Maggie, weighs 14 ounces at birth. She doubled her weight within 10 days. Assuming her growth is constant, that is a key thing to think about. The growth is constant. How much will she weigh at various times in the first year? So, table again, X and Y values. Now, X, what is X talking about? Is it talking about the ounces or the weight of the dog, or is it talking about the days? Again, X is your independent variable. So that means the other one depends on it. The Y is a dependent variable. So does the weight of the puppy depend on the days, or the days depend on the weight? And the correct answer is the weight depends on the days. So the weight is the dependent variable. Weight of puppy. And this over here is the time, or the days, okay? All right? Well, if she weighed 10 ounces at birth, we start right here. Well, what's a good time to start? 0. Now, careful here. At 0 minutes or 0 days, how much did the puppy weigh? And the correct answer is not 0. The puppy, when it was born, weighed 14 ounces. So 0 is 14. Now, grows within, the puppy doubled its weight within 10 days. So 10 days later, it doubled its weight. So it went from 14 to 28. Now, what is next? What would be a reasonable amount of time next? Well, 20, I think, would be reasonable. Now, here is the next tricky part. What is the next number? Is it 56 or is it 42? 56 or 42? Think about it. Do some work if you need to, but which one do you think it is? Well, got it? Got your answer? We got to go back to this. The growth is constant. What does constant mean? It means it goes by the same amount every time. So right here, it grew by 14, or it doubled. The question is, does it double again, or does it add 14? Well, if it grows by a constant amount, that means it must grow by the same amount, so it's not doubling, it's adding 14, which means it would be 42. Then 30, we add 14 again, and we get 56. And at 40, we add 14 again, and we get 70. And we'll do it again at 50 days, we add 14 again, and we get 84. So that, again, it says within the first year. Now, yes, ideally we'd go probably a little more, but we're just going to go right there at those points right there. What quadrants would it be? Well, again, look at all the values. They're all positive, so I'm going to make my one quadrant graph right there. And let's see if I learned. Nope, I made this bar, the x-axis probably a little too long, didn't I? So I'm just going to go here, 0. I like leaving 1 and putting, leaving 1 square and going by tens, which means each square is actually worth how much? It's actually worth 5. So every square is actually worth 5, but I just don't write the numbers in between. So I'm going from 0 to 50, and this is days, or time in days technically. Time since birth in days. And then over here is the weight. And again, you are copying this down. You need to include these pictures in your notes to get credit for it. So please make sure you have it. And I think over here, I'm kind of, look at that, 84 again. So it's really very similar to my other graph. So I'm going to say every square is worth 10 here. I'm going to label every other one. So 40, 60, 80, 100, and now plot my point. So actually I want you to plot your points, pause the video, plot the points, and then unpause it when you're done to see if you got the same thing I got. Okay, here we go. 0, 14 would be right about there. So this is 10, this is 20, 14 would be a little bit below that. 10, 28. This is 30 here, so if I go over, 10, 28 would be somewhere around there. 20, 42, well that's easy, 40 is right there, so it's a little bit above 42. 30 is 56, that one's going to be a little tougher. Here's 50, so 56 would be a little bit above that. 40, 70, oh awesome, nice, right on the point there. And 50, 84 would be somewhere around there. Now in this case, the time and the weight can increase at a constant rate. So we are actually going to connect the points here. Just make sure you can still see your points, the dots that you had here, and hopefully it makes sense. And that right there is what you should have. All right? Okay, ladies and gentlemen, I hope you got that. That is our notes for today. That's our video for today. So we are done with that. Your task now is to just be ready with this for tomorrow. Again, if you need to pause the video to make sure that you have that copied down, please pause the video. Otherwise, I will see you tomorrow.